What do I got? I got 22 people here. I'm only missing, I don't know, how many do I have now? I'm missing about 15, I think. That's not good. People waiting in the wrong place. Let me see. Hold on, guys. Sorry. Somebody's. Oh, good. They made it. Okay. Sorry.
It's a
Anybody else
different
have?
Zoom link each week, right?
Yeah, each week I'm gonna make a new link that kind of
Okay,
is.
is it possible that anyone went to last week's Zoom link?
That's what I was just checking out. It doesn't look like they did, or else I would get a message saying. I did get a message that somebody was at the other link, but they are here now, so that's good. So it looks like they figured it out. But I appreciate that suggestion. All right, now, and I do that every week because it's supposed to help with decrease the probability of Zoom bombing. Have any of you ever been involved in a Zoom bombing? Do you know what that is?
No.
That's when your class or whatever the Zoom meeting is, somebody comes in that was not invited and just starts doing horrible things. So one of my colleagues, they were putting up pornographic stuff and saying horrible things, and they did it at the Senate meeting too. When we had the presidential candidates giving their speeches, they came in and Zoom bombed it. Anyway, so we do everything we can to kind of keep that to a minimum.
New hobby.
Yeah, it's every teacher's new hobby now is figuring out what to do if that happens. Now Zoom has this one button I can push. It's the security button, and it'll just lock everything down if something happens. So, not a power I ever wanted to have. Anybody else questions before we get into?
I have one more.
Yes.
On 2.486, China doesn't have a box.
Okay. Let's take a look. So what could that mean? They do have a box. They do. They got one. They do. It's just been smushed. It's smushed. Poor little thing. So what is up, real quick, what is up with Germany? What's Germany missing?
Germany, wouldn't that mean that the median? No, the median's the same as the Q3.
Yeah, Q2 equals Q3, exactly. So could you imagine a situation where even this was the same? So you would have a picture like this. So this would be if Q1 equal Q2 equal Q3. Are you with me?
Yes.
Mushing the box, mush. Now what if you took that and you smushed it to an end? So here the low equals Q1 equals Q2 equals Q3, and this is the high. Can I make the letter H? Nah. You guys okay out there? You guys with me?
But then how would you know what side China?
I agree. That's the mistake the book made. They were pretty good here. See how they made that dotted? So they should have made this dotted, but even without that knowledge, you can still say either the low or the high are also the other quartiles. It's got to be one side or the other.
Wait, that wasn't a problem from the homework, was it?
Totally was. Section
86?
Section 2.4.
Yes, because I got it wrong.
Oh, we had to go all the way through 2.4?
All right.
Okay, sorry.
That's all right. And just to make sure, Billy, you know the homework sheet. You definitely know the homework sheet.
Yeah, I do. I know the homework sheet.
And the due dates, you know where the due dates are.
Yes.
Okay, good. And I think 2.4's due date. I can't remember now. What is 2.4's due date?
I'm looking it up right now.
Yesterday.
All right, it might have been yesterday. It sounds like. Now all right. Let's have a discussion about homework in general. All right. Quick little shout out to my people that have discovered the solutions manual somewhere. Stop copying. Thank you. I know a lot of you guys aren't, and I appreciate that so much. But I used to make a joke about answers will vary. Have you guys ever seen that phrase in the back of the book or in a solution manual? Answers will vary. Yes, no, maybe, no. And I used to joke, this is about 20 years ago now. I used to joke, yeah, someday and now it's like every semester somebody's got answers will vary in there. I'm like, good Lord, make it harder for me to tell that you're copying. No, it's okay. It's okay. Get over that. Get over that. If you've cheated and I understand the pressure, I understand all that shit. Trust me. Just stop doing it. Right. Homework is going to end up not counting nearly as much as quizzes or tests, midterm, final. So it would be fantastic to do the homework and make a lot of mistakes. Why is that fantastic? Because that represents what you know. And when you make mistakes, you figure out why they're mistakes, and then you don't make those mistakes on the tests. Are you guys?
This might be another stupid question. Where do we find our grades? I keep seeing 0 out of 0 for everything.
Yeah, I don't do grades yet. We haven't really had anything except for the first quiz, but all right. Your current average is your quiz grade. That's the only thing we've gotten so far that's really graded. I don't throw in the homework grade till the end of the semester because I allow late homework and I allow you to correct it up until the end of the semester.
My quiz grade says 0 out of 0. Oh, 61 out of 100? What?
If you want to broadcast it, you can.
I thought I got 100 on it. It seemed so easy. It seemed too easy, honestly.
Yeah, I remember your comment, and I said, no, be careful. All right, but remember, so since Billy brought this up, you're not the only one that scored a low score, Billy. Everybody, if you didn't make 100 on the quiz, you can make corrections. Don't erase any original work on another sheet of paper or on the same paper if you can make it really clear. Correct the ones you made mistakes on and then resubmit it right in the same place. Is everybody with me? If you want to, you don't have to. It's up to you.
Where do we find the one that the graded one so we can see our mistakes?
Okay, all right, let me show you.
Real quick, on the submit quiz one here, it says that this assignment does not count towards a final grade. I had a feeling that it would be, you'd probably have an explanation for that one.
All right, I do not let Canvas calculate averages because it makes mistakes.
Okay, so that's just more of a Canvas thing, but it does count towards our final grade.
Of course, it just doesn't count towards the Canvas doing anything with it. So normally after the midterm, I'm going to add into Canvas 3 grades. What your average is, not including homework, what your average would be with no homework turned in, and what your average would be with perfect homework. Are you guys with me so far?
Mm-hmm.
So I do that so then you can kind of tell where you are relative to how much homework you've turned in and how good it's been. Are you guys? I don't really calculate the homework grade until the end of the semester because that's when it's all really due, corrections and all this stuff. Is everybody with me so far about this?
Yeah, it's just hard to correct something when you don't know what you did wrong or right.
All right, so this is why I've had this up here since before the class started. A little video in the announcements. And this works for homework, it works for anything I grade. I should have just put graded stuff. So if you watch this little tiny video, it's like 2 minutes, I think. Not even 2 minutes, it's 1 minute and a half. Right?
Very quick video right now.
Watch what you can do. You can speed me up.
How you can access the notes that I put on your turned in assignments.
We're not going to watch it right now. Is that all right? Can you do that?
Yeah.
And I think I've even shown you guys. Haven't I shown you guys how to view feedback on things? So if you hit your grades button and you see something that's graded, you click it and then you click view feedback. That's basically what my 1.5-minute video shows you. If you hit view feedback, you can see what I wrote. This is just shit I turned in, just as an example. Are you guys, is that all right? Okay, all right. All right, now.
Yeah, and I turned in some stuff that I haven't gotten any check X or anything for.
Oh, hell yeah.
It was turned in a little while ago.
Everything
Music.
that people
Not
turn
great.
in from chapter 1 before the first quiz, I grade it. If you turn stuff in after it's been quizzed on, I'm not going to focus on that.
I turned it in before the quiz.
What stuff is this? Chapter 1 stuff?
1.3 and 1.4 and 1.2.
Oh, it might have been, I don't know what.
It was late, but
It was late. Okay.
but
Yeah.
not after the quiz late.
Okay. All right, that's fine. But okay, it was late. Okay. Yeah, so some of that stuff I haven't gotten back to either. So if you turn stuff in on time, if you turn stuff in before the quiz, I will do all I can to grade that. Because I'm just me in this place. I'm only one human, can only do so much. If there's something that you see I haven't looked at and the quiz is coming, you're like, can you take a look at this, Mr. Waller, and just tell me, right? Communication is amazing. Okay. Anybody else? Anything else?
Me.
Yes.
I have one question on the 2.7
2.7. Okay.
and the 69.
Okay, let me see. 16. There. All right. Oh yeah, you're back here. Shoot. Hold on. Here. Okay. So, all right. This book is in love with the graphing calculator. I think they have some agreement between them. You know better. In fact, today I'm going to show you how to use the graphing calculator to fill in your table. So whenever I ask you, let me say it like this. After the midterm, I will allow you to use that 1var stats. Do you guys remember 1var stats? That we can get the X bar and the S and the sigma and the 5-number summary. I will allow you to use that to get your standard deviation quick, right? But definitely on this homework, on the quiz, probably on the midterm, I'm going to need you to create the table that we did together in class. That's on the handout that I'm going to show you in a minute, remind you about. Remember, I have a standard deviations handout that has, okay, we're going to do that a little bit together here in a minute. Is that what you're asking about?
Yes.
Okay. All right, so let's do this. Let's take a look at this handout. All right. There we go. Let me become a student so it looks like yours. Become a student. All right, there we go. So if you come down to Unit 2, you'll notice a couple things. So this has been up here for a while, the standard deviations handout. And we're going to go over the other side together here in a minute. Something that's a little new, I think I unlocked this like Saturday or Sunday. So this is sort of a practice quiz in a way for the chapter 2 quiz. Right, so this is here for you. You can try these out. And I also unlocked the solutions video for that worksheet. So you don't have to do it. Please don't turn it in. I've got the solutions up here, right? You guys, everybody understand what's happening? So I did put a practice quiz, essentially, is what this is, except for the standard deviations, which is here, and the solutions video for it. So let's do this. There's no questions about that. Let me shift to a better way to do this. Jeff. Oh, there we go. Okay. What are you called again? All right. So he's talking to me. Standard deviations. Where are you? You're 2126 practice is like quiz 2. Yeah. So quiz 2 is going to be all of chapter 2. so that, all right, let me make sure everybody understands. So between the standard deviations worksheet and this, that's kind of like together, that's like a practice quiz 2. Is that cool? All right. So let me do this. Hold on. Sorry, guys. Oh, so much technology. Sucks. Okay, here we go. Summer. Bam. Ship protect summer. All right, here we go. All right, guys. Oh God. Oh. All right. So I pointed this worksheet out to you last time, I think. So I want you to notice something. I have identified the way that you can use your calculator to accomplish these columns. Does anyone remember doing this together? Why is there a square here, for example? Does anyone remember why that's a squared there? Anyone?
To make
Make it not negative.
Yes, to make it positive, to make it not negative. I like that. Because otherwise it would always add up to be 0, which is not very informative. I like it. I like it. So that's why at the end we take a square root, right? Does that make sense? That's kind of cool. Now, good. So I've identified on this sheet what you would plug into the calculator's lists to have it create this table for you, and then you can just copy it down. Isn't that nice? So then, Jeff, why won't you just let us push the 1var stats and get the answer in one go? Because, that's not learning shit. You got to go through the process, sees what go into something, because then my hope is you'll understand a little better if you see what goes into it. So this is kind of a reference for a completely worked out problem. So let's try this problem here together. All right, so take a minute and throw these data points into your calculators. I'll do the same thing. Shit. Hate data entry. Oh, yes, that sounds about right. Thank you. So, I mean, to do the mean, you don't actually have to plug it in your old calculator, right? You just add them all up and divide by, there's 12, right? So what do you actually get? You get 78? Is that what you get? Yeah. Is everybody cool with that? Right? You add them all up, you get 78, and then you divide by 12 because there's 12 people's grades. So the average comes out to be 6.5. I like it. All right. Are you ready for a dumb question? How can you tell this is a sample? No. 12 people
They're
could be.
not in order.
Nope.
It says sample.
It says sample. It says sample. So be really careful. Is there a difference in the formula if it's a population versus a sample?
Yes.
Yes. And I like the way Melody put it. This is exactly what I meant by kind of not the smartest question, but people miss that. People just miss it. But if I say it's a sample, it's a sample. Okay. I like it. So then that's why this formula has an n-1. Remember that? Remember that? That's the adjustment for it being just a poor little sample. Does that sound familiar? We had a whole discussion about my degrees of freedom. And I say that like I'm in Braveheart. If you don't know what Braveheart is, it's an actually okay, it's a good Mel Gibson movie. There's a few of those from before, and then he went insane, and then things happen. All right, so you got all this in your calculator? So let me share my calculator here for a minute. All right, here we go. What I'm gonna do, can you guys see my calculator? All right. You don't have to do this, but I'm gonna sort my data just because. There's really no need for it, but I just like to do it. So here's my data. Right, there's my data. What do you need the second column to be? What is the second column in general for standard deviation calculation? No, second column is not the mean. It would just be 6.5 all the way down. No. What's the second column?
Standard deviation.
No, I don't know the standard deviation yet. That's what I'm trying to figure out. All right.
Distance from the mean.
Yes, distance from the mean. I like it. So it's supposed to be this. Yes, it's supposed to be x minus x bar. Why does that make sense? Stay with me, guys. Stay with me. Stay with me. What is the standard deviation supposed to tell you? What is the standard deviation supposed to tell you? It's supposed to tell you.
Average distance from the mean.
Good. To what?
All the data points.
All the data points. So the average distance from the mean to all the data points. Right? That could be a question I ask you on something. Yeah. Standard deviation tells you the average distance from the mean to all the data points. So therefore, it makes sense. The first step is to freaking figure out how far all the data points are from the mean, right? Okay, now, where are my x's in the table? Not what are they? Where are they in the table? Where did I put the x's? L1, I love it. You guys with me? I haven't put them there yet, but that's where they're going to go. 2, 4, and whatever. 6, 6, blah, blah, blah. Stay with me. And then I want to subtract the mean, which is 6.5, correct? So aren't the x's in L1? Isn't the mean 6? I really want you to see how to control your lists. Don't I want the second column, L2? I want L2 to be each thing in L1, each of the x's, minus the mean. Isn't that what I want the next column over to be? Just subtract the mean from all the x points. Let me show you my calculator again. Here we go. Something tells me there's a better way to do what I'm doing here, but I won't. Now, so if I go up to L2, I can control the entire list. What do I want that list to be? I want it to be all the x's. Okay, they're in list 1 minus the mean. And then, bam. That's very satisfying. If anybody's ever used Excel before, we would probably teach this class using Excel if we had enough computer labs to do that, but we don't, so that's why we don't.
Okay, how did you just do that?
All right, I'll do it again.
For the slow kid in the class.
You're not the only one. Don't worry, Billy.
Okay.
So you go over and then you go up because I want to put something in the entire list. So highlight the list. And I want that next list to be, I want everything here to be the X value in that row minus the mean. So the X values are in list 1. And I want to subtract 6.5 from each of those. Why 6.5? Because it's the mean that we calculated, right? And now, this is the first thing I reminded you about. What do I want to do in the next column? What do I want to do to all these things in list 2?
Square.
Find the distance from the
No, list 2 does that. But like somebody else said, I want to square them to kill the negatives, right? So I want to take everything in L2. There's L2. So hit second 2, and I want to square them. Now let me see. Let me do a mistake real quick. Look what, I'm in the right place to control list 3? No, I'm in the first spot. That sucks. So if I try to put L2 squared here, the calculator's being like, what the shit? Right? Data type. What that's really saying is you want me to put a whole list into one spot in the list. I can't do that. I'm like, oh, I'm sorry, calculator. So I need to highlight the list, and then I can tell it I want list 3 to be everything in list 2 squared. Yes, 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 yes. So then you would, if this was a quiz or homework or a test or something, you would copy all that down into the table on your sheet of paper, right? Now, if only there was a quick way, because, all right, let me come back. Well, all right, can you guys all see your sheet that we're working with? What do I want to do? Well, let me show you. What do I want to do with everything in that third list? What's my formula say that I need up here on the top? Where would I get this from? What does this mean? Can somebody read this to me? What does the top here say?
The sum
Sum of?
x
Minus
minus
x squared.
Yeah. And where's all of the x minus x bar squared stuff? Where is it?
the third list.
Yes. So what this really says is sum up the stuff in the third list, right? Based off of what we've done. Are you guys, does it make sense? You don't have to write that shit anytime. Don't, in fact, don't. Let me just take that away. But I know here's all my x minus x bar squared stuff. So now the top is supposed to be the sum of everything in this column, right? Okay. So is there a quick way, Jeff? Is everybody with me? Anybody lost? Everybody's okay at the moment? All right. So there's kind of two ways to do this, but the way that's better for right now, I think, is this. All right, so you've got a little bit of a taste of how to use your lists. And your lists really help you do math to a lot of different numbers at once, correct? And if you've ever used Excel, this should feel very familiar. You can control a whole bunch of stuff at once. One of the most important buttons on this calculator is not on, it's not stat, it's quit. If I want to get out of something, I hit second mode, I quit. I get the hell out of there. Okay. Then I'm gonna, what I want to do, what is it that I want to do right now? What is it that I'm trying to get right now? Anybody remember? What am I trying to do?
Sum of x minus x bar squared.
Yeah, I'm trying to sum up one of my lists, correct? So it kind of makes sense. I'm gonna go to this little thing that says list. And I want to do math to one of my lists. I want to sum up one of my lists. Watch what I can do. I can just hit the number 5. And to see how it's waiting, it's got a parenthesis. Of course, I want to put in there, I want to put L3. I want to sum up L3. Bam. All right. Let me do that one more time. So here's my lists. Here's my lists. Hold on, somebody's chatting at me. If I hit, I want to quit, because if I don't get out of my list, it's going to try to put the answer into my list. And that sucks. So let me get out of my list. Let me get the hell out of there.
Yeah, I just did that.
Yeah, all right, you lived the experience. Okay. Go to second step to go to list, and then I can go to math, and then I can sum up second 3, L3. Bam. Okay. I love it. You guys are easily amused. That's good. That's a good way to be. So you guys are like, wow, that's cool. All right, it's not that cool, but it's okay. It almost makes the calculator worth the money. Thankfully, you can do more shit. So let me come back to this thing here. Oh shit. So can somebody help me out? What goes up top here now?
69.
69. I like it. So that is because that was the sum of all these things. I'm still gonna have somebody do this weird stuff. I don't even know what, I don't know. You can't put stuff in here because what is X? It's all of these up here. All of these are X. So you cannot plug stuff in. This is one big variable. What is the sum of these? Oh, I know it's 69. What goes underneath?
12 minus 1.
Yeah, 12 minus 1, so 11. So what is my variance? What is that squared?
6.27.
Is it 6.27? Repeat it. 0.272727.
Yes.
Okay. Yeah. Now let me show you something on the calculator again, real quick. All right. So if I do 69 divided by 11, I get that. And then I want to take the square root of that. A huge thing to understand about a lot of math and science and so forth is you try not to round too much before the end of a problem. So don't just take the square root of 6.27, take the square root of all this shit. And that's what this ANS button does, remember? Bam.
But you still won't get a discrete number. It's still continuous.
All right, I need you to be really careful. Numbers cannot be discrete or continuous.
I mean, the answer is a continuous.
No. So you're just saying the answer's got a lot of decimal places, right?
Yeah.
Okay. Of course, definitely. Whenever you take square roots of stuff, they're almost always going to be irrational, meaning they're decimals that go forever, right?
Right.
There's only certain numbers that you can take a square root and comes out nice, and that would be stuff like 4, 9, 25, 16, 36, all that kind of shit. Okay, now, what is it we just figured out? I love you guys. You're like, I don't know what we're doing, man.
The variance?
Well, no, we already knew the variance. What did we just figure out? Standard deviation. Yeah, we took a square root. That's when it became, was it 2.504? I can't even remember. So what does that mean?
It means the number and every number less than it.
No, you're thinking about percentile, I think, maybe. What did we say at the very beginning that a standard deviation means?
The distance.
The average distance from all the data points to the mean. Yeah, so on average, all of these data points get this far away from the mean, roughly. Let me stop for a minute.
I was thinking of cumulative standard variance. I'm sorry.
Oh yeah, there's no cumulative variance or anything. You're thinking about cumulative relative frequency, maybe.
Yeah, that's what I'm thinking of.
Gotcha. All right, now. Here's the next thing. Okay. So in statistics, you always have the technical, how do you do this shit? And then you always have the slightly more important, what the hell does it mean that we just did? What does it mean? The way,
Yeah.
Sorry, did you have a?
I have a question.
Yes.
Yeah, I have a question. So you put 11, like divide by, 69 divide by 11?
That's right, because 69 was the sum
Yeah.
of these, right? And 12, and n is 12. So 12 minus 1 is 11.
Oh, okay, minus 1.
And if
Yeah,
this would have been
thank
a
you.
population, I would have divided by just n, because then I have all the information.
Oh, okay. Yeah, got it. Thank you.
You're welcome. All right.
So wait, it's which number minus 1 at all times? And
It's,
why
yeah.
does that make mathematical sense?
All right, so all right, so I could say this. We discussed this a little bit before, but here's the thing. Let me connect something that we discussed. Remember n minus 1 was the degrees of freedom, how much freedom I had before I had to get serious?
Mm-hmm.
You guys remember that? Like, if I have 3 numbers and they have to average to be 10, I can make the first 2 numbers up, completely make them up. Doesn't matter what they are. But that third number, oh shit, I have no freedom with it. It's got to be the number that makes the mean come out correct. Are you guys with me?
Right.
Now, this sample is probably from a class. Let's pretend like there's about 40 people in the class, correct? Let's just say there's normally about 40 people in a class. Are you guys with me? Right? Would you say that the average for everybody is probably 6.5.
No.
I would put a lot of money on the actual average. Maybe it's close to this, right? Especially if this is a good random sampling, but it's probably different somehow. Is everybody with me? That's something you should come into this class knowing. A larger sample is better. If you had everybody, that's even better. Why is it better? Because you get closer to the truth. So the smaller the sample is, the more likely it is that whatever you see is further off. So this is something we know even before this class started. All right, now, n minus 1. So 6.5, do you all agree it's not the right average? Is there a number? Now stay with this is where we get weird. Could I add one more number to this to make it the real mean? Like if I knew what the population mean was, let me make sure you guys are really with me. If I knew the population mean was 7, could we figure out a 13th number here to make the actual average correct, to match the overall average? Could we do that?
Yes.
You know we could. We sort of did that already. We did that when it was like make shit up, and then we had to get serious on the last one. So here we saw like we made all this shit up, and if I knew the real mean was 7, we could figure out what the 13th number is. So then in a sense, what this is saying is we have n minus 1 things because we're kind of missing the correct number to make the average come out right. This isn't quite the whole story even yet, but that's closer. That's kind of closer to it. So with a sample, the idea is since the average we get from a sample is not correct, and since the data points in a sample will always be closer to their own average, I want to make this come out bigger. Because naturally it would be smaller if I use the exact same formula. That's the whole thing we built up before. Now, can I get really deeper right now into why it's exactly n minus 1? No. We either have to do some really funky ass math or we'd have to do a problem that would take us a week. But anyway, so hopefully that's okay for now. So the best way to look at it is an adjustment because it's just a poor little sample that can't possibly give us the right mean. So it's an adjustment for that. Okay. Now, the thing I was about to say, the right way, I feel so bad for you guys. So, summer, I'm throwing a lot of shit at you every day, but we all know that. It's the reality. We chose this class. It's the way it is. I look at standard deviation like steps. If my city, if you wanted to go explore a city, has anybody ever been to Denver? I think Denver is just, to me, it's really weird because I'm used to being in cities. I grew up in cities that were like really compact, but Denver sort of like spread out. So if you wanted to explore Denver in a day versus explore Salt Lake City in a day, wouldn't your trips have to be larger to cover the whole place? I don't know if I'm making any sense. So, all right, let me get up here. Let me stand up. So if you have data that look like this, hold on. They look like this versus data that look like this. If here your step size was this big, wouldn't you miss everything if you took one step? You guys with me? I have no idea how you feel about this. This is the level of explanation that I never want to see from you on a test necessarily, but it's just to understand the idea, right? So standard deviation will change with how spread. So this one, it would make more sense for the standard deviation to be this. So then I can kind of step around my data and kind of explore. Down here, I would maybe want a standard deviation like that. And that's why it makes sense to have standard deviation be the average distance from the mean to all the data points. It's how big your step should be if you want to kind of move around in your data. All right, now let's do this. All right, so watch this. If let's say this is the mean, so it's like it's 0 steps away from itself. The mean is 0 away from itself, correct? If I go 1 step up and 1 step down, so down here, what would that look like? So here's the mean, go 1 step up and 1 step down. Okay, now stay with me. The same percentage, so if these are normal distributions, both of these are normal curves, there will be 68% of the data in here.
Is that just always the number, 68%?
It's actually
In a normal curve?
to be completely honest, it's actually 68.26 maybe. I can't remember exactly. So we kind of round it. So it's not exactly 68, but the reason I say it's 68% is because it's always about that for any normal curve. I don't care how fat it is, how skinny it is, how smushed it is, whatever. Any normal distribution will have the exact same probabilities distributed in it. Whereas if I had a distribution like this, and I go 1 step out, I might get nothing. I might get like 2%.
So what is the 68% consist of? Like,
So I like it. Good question. If I had, let's say this is heights of men. And the average height of men is 69 inches. And I think the standard deviation is 2.8. So stay with me. What would 1 step up then be from the mean? What would the height be?
70?
71.8.
Yeah, each step is not 1 big. Each step is 2.8 big. Do you see?
Okay, so how do you calculate that? The 2.8, how did you get 2.8?
Oh, I'd have to have all the data available. So I got this from a website that dealt with large samples of Americans. This is all about America, by the way, because other countries have different averages. From medical records and stuff like that. You guys kind of with me?
Okay, so that's something you have to derive once you have all the information.
Exactly. So either they're
Okay.
going to give it to you or you're going to have to do it in a table like this one is, right? So I could have given you a table of a sample of Americans and you could have calculated this average and this standard deviation, right? If it was a sample of ENS, but oh, are you kind of with me? Stay with me. Now, what would this be here?
A negative value.
No, definitely not. It's 69 inches. 1 step up is I add a step. 1 step down is I subtract a step. What's 69 minus 2.8? $69 plus 2.8 is 71.8. 69 minus 2.8. Are you guys?
66.2.
Is everybody? Are you guys okay out there?
I'm behind you. I'm still doing the list entering on the calculator and getting the formulas. I can't figure out how to do absolute value on the calculator.
There's no absolute value to do.
Oh, it's just L2. So L3 equals L2 squared. That's all you enter in. And
Yeah, L3 is L2 squared. Yeah.
Okay.
Maybe hold off on that. We'll come back to that. Just pay attention to this. So underneath here, what I could do is, isn't this 0 steps away from itself? This would then be 1 step above, and this would be, and maybe this is what you were thinking about. This is 1 step down. Is that cool?
Mhm. Yeah.
So what percentage of American men have heights between 66.2 inches and 71.8 inches?
68%.
8%. Hello. So if you wanted to know, let me go one more step out. So if I go one more step up and one more step down, we end up catching 95%. Rounded. You guys with me out there still?
Mhm.
Doesn't this kind of make sense? Because let's go up and down one more. So what would this be? So 66.2 minus 2.8 is 63.4, and then 71.8 plus 2.8 is 74.6, I think.
Yeah.
So what is 74.6? That's 6 foot, 2.6 inches, right? And what is 63.4? And that is 5 foot, 3.4 inches. Are you guys all with me?
Mm-hmm.
And this is men. How many, does it make sense that 95% of all American men are between 5 foot, 3.4 inches and 6 foot, 2.6 inches?
Yes.
Yeah.
Yes. Yes. Wouldn't you expect most men to be in the middle? Isn't this over half of all men are right there in the middle, right? In fact, me, I'm like right there. So my basketball dreams got smashed pretty early when I stopped growing. It's like, okay, that's out. Now,
Wait, how did you get the number 2.8? I'm sorry.
it
That's
was
the
given.
standard
I
deviation?
gave it to you. I gave it to you. How did I get the number 69? I gave it to you. So it's a known fact. It's probably changed a little bit since I last checked, but it used to be 5'9" roughly was the average height of American men. And if I remember correctly, it was 2.8 inches was the standard deviation of American men. It's probably changed a little bit since I last looked it up, but it's pretty close. So I'd either have to give it to you, or the problem we were doing on the sheet, you could calculate it yourself in the same way. Okay, maybe. Now, what can somebody tell me what percentage of men are there? What percentage of men are up here?
95% minus 68%.
No, I appreciate what you're doing, but that would be more like in here in a way, it would actually be both of these. If there's 95% in, how much is out?
5%. So 2.5% on each side.
Beautiful, there it is. Kick ass. Good job. So if I wanted to have a room with a door that only 2.5% of men would have to duck to get through, how tall would I make the door? 74.6 inches tall. Are you guys understanding what I'm saying?
Mm-hmm.
Now, this is a fact. Have you guys heard that airplanes had to make their seats a little wider to accommodate the ever-growing American ass? Yes. And actually, after the pandemic, some of our asses have probably grown a little more. I understand. So if you know the average hip width or butt size or whatever you want to call it, and you knew the standard deviation, you could actually calculate very specifically the percentage of complaints you might get. Does that sort of make sense? So if you make it wide enough to cover 98% of people, then you're going to get complaints, or you're going to have people, whatever 2% are going to give you trouble. So these are easy calculations to make that businesses do all the time. And then they have to weigh, well, what's going to cost too much either in the first place to make it, or afterwards in terms of PR, in terms of public relations, right? Get a lot of complaints. People are going to be like, screw your place. Maybe you start to see the utility of this kind of thing. Maybe. No. Okay. By the way, if I went out one more step, it would be, I would catch 99.7%. Crazy. All right, anyway, sorry. So let's look back at this sheet. This is going to become really huge again in chapter 6. So we sort of lay the groundwork now because it's all built off of standard deviation. Oh shit, was I sharing that whole time? I'm sorry, guys. Why did nobody complain? I'm up there on the board. It must have been so tiny.
If you swap the view, it could make you bigger.
Yeah, I
Okay.
swapped it too.
Everybody was okay. But yeah, let me know if I do that. I obviously didn't mean to. I wanted to. I'm sorry, guys.
How many dogs?
Huh?
Oh, sorry, talking to the dog.
Oh, okay. Okay. Let's see. All right, let's come back here. So, let me ask you this. All right, so 2.504 is my step size, right? This is how we talk about it in like colloquial ways, right? This is how big the steps are. Can somebody tell me, so the mean is 6.5. Could somebody figure out how many steps away, what is it, 8? How many steps away is 8? So that's a weird question. What would one step above the mean be? So if the mean is 6.5, what would one step above the mean, where would I end up? If I took one standard deviation up from the mean, where would I end up?
At 9?
Yeah, like 9.004.
Mhm.
Okay. Is everybody okay with that? All we did was we added one standard deviation. 1s, right? Okay, so added 2.504. But so let me ask you the other way then. How many steps away is the number 8? How the shit would I do that? Well, how far away is the number 8 from 6.5? When I do 8 minus 6.5? Now listen to me, listen. So what I'm really asking is how many steps fit into that, right? And in mathematics, if I'm trying to figure out how many things fit into something else, that's very often division. If I divide this by the standard deviation, I will get the answer of how many steps. Is it a full step to get to 8? Do I take a full step to get to 8? No, because one full step would get me to 9.004. So this is definitely going to be a fractional part of a step. Yes? So what would you get if you do this? Somebody help me out. What do you get when you do this in the old calculator?
0.599.
Let me think. Does it make sense, Jeff? 1.5.6.
Because when you do 8 minus 6.5 divided by 2.504.
Oh, 504. I'm sorry. You're right. I put 054 up here. All right, now it makes more sense. All right, who's talking to me? Let's see. 7302, yeah. I still think it's not quite missing. 1.5 divided by 2.504. Yeah, no, we get 0.6. You might have done it with my turnaround number. I'm sorry. Yeah, that was my fault. Okay. Oh. Okay, now, is everybody with me? So what did we just figure out there? We figured out how many steps away it was from the mean to 8. So if you're the student that scored an 8 on this quiz, did you do better than average? What was the average?
Yes.
So yes, you did better than average. And now we've measured it even more precisely. How far away are you from the mean in terms of the average distance to all the data points? You're about 0.6 steps away. It's positive, which means in this case, it's a good thing because the higher the grade, the better. So positive z-score means above average. I'm sorry, I just said a word that I haven't introduced yet. This formula, what was the 8? What's the 6.5? It's x bar, correct? 6.5 was the mean. And on the bottom, 2.504 was the standard deviation. And then the first number was just some data point. We call this a z-score. All the z-score tells me is how far a data point is from the mean in standard deviation. So let me say this again. Okay, I love you guys. Oh, so much on a Monday, I know. So much on a Monday. Oh, okay. Got somebody shouting at me. Hold on. Whoa. Oh. Okay. Wow. All right. All right. I'm gonna have to address that later. Come at me with that later. It's a little much to take care of right now. What was I saying? All right.
Z-score.
Z-score, thank you. Z-scores are crazy, crazy important. If your Z-score on a test was -3, how should you feel?
Bad.
How bad?
Very bad.
Very freaking bad. 3 steps down is stupid far below. That's bad. That's like, whoa, I'm really, really sorry. So what we're going to do as we go through this course, and we use Z-scores more and more, we're going to determine, we can just tell if somebody says a Z-score of 0.07, we're like, well, that's really close to the mean. Somebody else is like a Z-score of 12, we're like, holy crap, that is way far away. That's somebody way out there. So if somebody is really, really tall, maybe their height Z-score is 3. They're 3 steps above the average in terms of height. Or if somebody's really short, then maybe they have a Z-score -2.3 or something. Like they're 2.3 steps below the mean. Okay. I love you guys. I love you guys. And do you see how the Z-score are these numbers here? These are Z-scores. Yes. This is 1 step down. That would be a Z-score of -1. That's 1 step up. That'd be a Z-score of 1. And of course, the mean would always have a Z-score of 0 because the formula says take the number minus the mean. So if something minus itself is 0.
Could you give the definition for Z-score again? Is how far a data point?
You ready? This is really, really important because the question, what does a Z-score tell you, will be on the next quiz. It'll be on the midterm. It'll be on the final. It's kind of important. So a Z-score tells you the number of standard deviations from the mean to the data point. So it is a distance. So here's the, oh geez, why am I losing people? People are dropping. Stay with me. Standard deviation is the tick mark we use on the ruler. Would anybody here measure the distance you currently are from the door to the room you're in? Would you measure that in miles? Anybody?
No.
No. If you did, we would look at you weird. We'd say, what the hell's wrong with you? Would you measure the distance from where you are now to Alpha Centauri, the star, in centimeters? The next star past our sun. Would you measure how far you are right now from that star in centimeters? No. Could you? Yeah, but would you? Shit, no. So standard deviation is a more precise way to think. Do I use inches or do I use miles? No, we use standard deviations. They are like the tick marks on a ruler. The Z-score is what I get when I lay the ruler down and I measure how far apart things are. I'm really hopeful for this. A Z-score is a distance, but it's not enough to say that. It is how many standard deviations from the mean to the data point. So in a way, it's the units on it are standard deviations. I don't know if you guys are with me. Are you? Oh, everybody. Okay, what's happening? Oh, that's nice. Everybody's being all nice. Yeah, okay. There you go. It's in the chat a few times too, if you want to see it written out. Good job, everybody. All right, now, let me think. Oh, we're not done with this. Oh, shit. Here we go, guys. So this one, part C, we actually did up here. If you'll notice, this was all the work here. So I don't call this a Z-score right here, but I might as well call it a Z-score now. All right, so this was the data point minus the mean divided by the standard deviation, and that's where we got 0.6. All right, now, has anybody tried to do part D? Let's try this together. Let's put the mean in the middle. What's one step up? We already did that earlier, didn't we? Wasn't that 9.004? Is everybody cool with that?
So we're using S for standard deviation as well as a short term as for mode, right?
What?
Or-
No, no, no.
What sample size? Sorry, sample size.
No, 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 no. What letter is sample size, guys?
The mu?
No, 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 no. All right. So you definitely, not a bad idea would be to have a page in your notes devoted to variables and what they mean. So somebody tell me, what does mu mean?
Mean.
Yes, mu is the population mean. What's X bar?
Sample mean.
Sample mean.
What's sample size? What letter is
N.
N? Yes, N is the sample size. I like it. And then you have S and sigma. What's the difference between S and sigma? What's the similarity? What do they both measure?
Standard
A
deviation.
sample.
Good. They measure standard deviation. What does S measure standard deviation of?
Sample
And sigma measure standard deviation of?
population.
So notice Greek for the moment means population. Greek population. Is that okay for now? Take that as an unenthusiastic yes. So what if I take one standard deviation step down? Where do I get to?
3.996.
Yes. Does anybody not understand where that came from?
I
Okay.
get it. And then the population between the 2 points would be half of 38, which is 34%. Right? So 34%.
No. Stop. I appreciate what you're saying. But what did this work with? What did all of these percentages work with? What kind of distribution did it have to be?
Normal.
Normal. Is this normal? No, I can look at it and tell this is not going to be normally distributed. So then how do you do this question then? Well, how many data points did we catch between these? That's what it's really asking, right? What percentage of the data? So the reason I like this question D is because we have a theory about what should happen if it's normally distributed. What's the concrete part of that shit? All right, well, theoretically, it's 68% if it's normal. Can't we just go see? How many data, did we catch the twos? Did we catch the twos in here?
No.
Sorry, one more time. What does S mean? I'm making the little code sheet.
S is the sample standard deviation, like sigma, lowercase sigma is the population standard deviation. Okay. Two's down here, right? Did we catch the fours in here? Did we catch the fours?
Yes.
Yes, we caught all the fours. We caught all the fives, all the way up to what's the last thing we catch?
9.
9. So can somebody help me out? How many data points have we caught then? Look back on my calculator.
Can you scroll back up a little bit? Thank you.
All of them but the 2. So 11.
No, what about tens?
Oh. Oops.
So all of them except the 2 and the tens.
Tens.
So we caught 9 data points. Yes, we caught 9 data points out of 12, which is what percentage?
75.
75%. So does it seem like this is a possible candidate for a normal distribution?
Yes.
Well, I'll accept that. It's not that far away from 68, right? But it is definitely not 68%, correct?
Mhm.
And a normal distribution is supposed to have 68%. So later in this semester, we'll discuss more exact ways to tell if something's normal or not. Because I want you to understand right now, if it's normal, I know a lot of shit about it. Yes, no, maybe. We could use You could go right now and construct a door such that fewer than 2.5% of American men would have to duck to go through it based on statistics. You could do that today. Right? So this is something you could use in the real world immediately. If you had the mean and the standard deviation, you could figure this out. I mean, and you just have to know it's normally distributed. Okay, so there's a lot there. But if we know it's normal, I know a lot of shit about it. So it's important to know, when do I know it's normal or not? Okay. Let's see, maybe, what time is it? Oh yeah, let's take a break. I have a feeling you guys need a break. I'm worried some of you guys have been already taking a break. Now, so let's come back at 3. Let's make it 2:55. I'll give you almost 20 minutes.
All right, can you bring that screen back up? I want to finish the work on it. Go through the break.
Where you at?
I
Can you
will.
post
The
this later
numbers
on?
aren't entered into the list, right? So if you could scroll up to the numbers, yeah. Thank you.
Well, you have access to this, and like somebody said, I will post this, like I posted the other ones. Yeah.
Okay.
All right, guys. So if you're good with that, you can go take a break. Come back at 5 till 3. If you have other questions, let me know. I'll stick around.
I have one.
Yes.
I used the formula for one problem from the book. I don't know if it's okay.
Used what formula? Sorry.
For the 71 and the 2.7. I don't remember what was the formula, but I don't know if it's okay if we can use the formula from the book.
Which is the formula that I just gave you, the z-score formula. All right, what formula did you use? Because it would be the formula that I just gave you.
Okay. I think, okay. Okay, I know. Okay, that's all.
All right, let me make sure, let me see, hold on. Let me show you, this is probably what you, well, actually, they do a really shitty job here, don't they? It is a free book. All right, let's see. Here we go. Where did they put this at? Yeah, they don't, do they? I don't know where. Yeah, I don't think they give the formula that I. Here we go. Here it is. Okay, finally. Hold on. Let's see. Billy, are you doing okay out there?
Yeah, I'm just doing this problem fully so that I comprehend what's going down.
I was going to share my screen out of the book real quick. Hold on. So here, at the end of the section, they have this formula. These are the ones we just used. So in general, if you don't know the population mean, use the sample mean instead. If you don't know the population standard deviation, use the sample standard deviation instead. So these are really the same formula. Right? It's data point minus the mean divided by standard deviation. That's what they both say.
Yes.
Okay. This
Thank you.
formula is this formula solved for X. We come back here. How's everybody else?
Well, I have a question.
Yes.
For the last one, I'm a little confused. Where do you get number 12?
Oh, are you cool with 9? What does a 9 mean?
Well, I think there's the number on the line. For example, 2, 3, 4, 5. I'm not sure.
So that's where you should start. So I like to think of this as a fishing net, even though I don't like fish. And then you say, what did you catch? Did I catch this fish? No, it's not in my net. Is 4 in my net? Yes. So I caught all the 4s. Is 5 in my net? Yes. All the way up to 9 is the last thing in my net, and then 10 escaped. Correct?
Okay.
So then if you count up all the 4s, 5s up to 9s, you'll get 9 data points that we caught. We caught
Oh.
9 data points out of how many? We caught 9 data points out of
How many?
12 total. Right? We caught 9 data
Okay, 12.
out of 12. And that's what a percentage means. Percentage is just part divided by whole. That's all a percentage is.
Okay, got it. Thank you.
What? Okay. Let's see, I could stop recording for a bit. I would have all the worksheets sitting next to me as I'm doing homework. I would have none of them sitting next to me as I'm doing a quiz because I know I can't use notes or stuff when I do a quiz. But I would sure as all hell have them laying next to me when I'm doing my homework. Holy shit. That only makes sense. Okay. Like homework 72, which value of team you want us to find out? All right. All right. There we go. Both. Yeah, so this one wasn't very well. So you have 2 different teams here, right? So you have one team's batting average and the other. You have one team's standard deviation and the other. Find the value that is 3 standard deviations above the mean. So do it for this team and this team. So you should end up with 4 answers, right? 1 for each team that's 3 above the mean, and 1 for each team that's 3 below the mean. Let's do one together. So let's look at Frito's team. Frito? Let's look at Frito's team. His mean is his team's mean is 0.166. And his team standard deviation is 0.012. So how do I find the value that is 3 standard deviations above the mean for his team?
You multiply the standard deviation by 3 and then add it to the number.
Yes. Add it to the what number?
To the average, the batting average.
Now, let me see. Stay with me now, guys. Stay with me. Here's the formula for a z-score, right? Or I could have put a mu and a sigma, but it doesn't matter. They're both me. Let me do that instead. Let me do that because we have a little population here. So let me use mu and sigma instead. Can somebody, all right, a little bit of algebra. How would you solve this formula for x? How would you solve for x? What's the worst thing about this formula if I'm something I have to solve? What sucks the most besides there's no numbers? What sucks the most about this formula?
The division.
It's a freaking fraction in there, right? Frickin' fraction. So how do I kill a freaking fraction if I don't like them fractions? How do I kill it?
You multiply.
Yeah, multiply by the thing that's making it into a fraction. Multiply by sigma. So multiply both sides by sigma. Here it dies, right? See it dying? There you go. The only good fraction is a dead fraction. Now, I wouldn't say that. Fractions are beautiful. Now, what's the last step now to get x by itself?
And mu.
Mu.
I like it. So I get x is mu plus z sigma. Are you guys cool with the way I wrote that? These are the same formula, just solved for different parts of it. Go ahead, sorry. What's up? Somebody's making noise out there. Okay. Now, what was this again? What did that represent, that number? What does this number represent?
The mean.
The mean. What was 3? Or let's see, what was 0.012?
The standard deviation.
Standard deviation, I like it. And what was the 3? Can somebody figure out what that 3 really means?
The z-score. The number.
Yes, because it's the number of standard deviations. So that would be z. Isn't that the freaking formula? Isn't that crazy? So if I wanted to say, what would a player have to do? What would their batting average have to be 3 standard deviations above the mean? They would have to get whatever you get when you add this stuff together. What do you get? 0.036, 0.202? Is that what it is? 0.036. 036. Yeah, 202. Okay. You guys, anybody not with me out there? Anybody with me out there? Anybody not sure what's happening? Listen, guys, listen. This happens all the time in math. Did we do this problem before I talked about this formula? Yes, we did, because it's an idea. Formulas capture ideas, and very often they have to make it look worse because they have to be the most general. So 3 steps above the mean. Okay, well, that's just 3 times this and add it to that. That's a simple idea, but that is what this formula captures. All right, let me see. Somebody's chatting at me. You're welcome. And real quick, last thing I'll say. I will give you the formulas, and you are not allowed to use notes on quizzes, midterm, final. You with me? But I will give you the formulas. That sucks so much that evil Jeff Waller does not let you use notes. But look at this. Stay with me now. One thing I told you I will ask you is, what does the z-score tell you? I told you I'm going to ask you this. I'm waiting for the day that I get more than half of my students get that question right. And I'm telling you, I'm going to ask you that question on the quiz, on the midterm, on the final. Look at this formula. How do I get it to a data point? I start at the mean and I go this many steps. If I start at the mean and I go this many steps, I get to the data point. I don't know if you guys understand. I'm trying to tell you that math is another language. If you can translate it, it's a note. What does the z-score tell you? You ready? What does the z-score tell you? The number of standard deviations from the mean to the data point. The formula tells you the answer. The power of math compels you. No, sorry. I don't know. Some of you guys don't understand what I'm saying. Formulas always can be directly translated into English. Well, let me be careful. Maybe not directly all the time, but most of them can be translated directly into English. All right. Anything else before we get into chapter 3? Okay. All right. So the nice thing is, I think a lot of you guys know a decent amount of the stuff we're going to talk about in this next section. If I told you that I had 10 pebbles in my hand, let's see. Hold on. Let me get up here. Let me get on the board. 10 marbles, let's say. Again, instead of pebbles. The 3 pebbles. If I've got 10 marbles in a bag, oh shit. Whoop. Right? And 4 of them are red and 6 of them are blue. What's the probability that if I pick one marble out, I'm going to get a red one? If I pick one marble, what's the probability that I get a red one?
4 out of 10.
Yeah, 4 out of 10. Right, which you can make into a percentage, which is how we normally communicate probability, right? Everybody should have either known that, or the minute she said that, you're like, well, shit, of course. Hopefully. So all a probability is at its heart is the number of things that match what you're looking for divided by the total number of things. So I was looking for a red marble. 4 things match that out of 10 things. You guys with me? So this could be 0.4, which is also known as 40%. I like it. That's nice, right? So some of this is going to be, it's going to be at that level, but you know it's going to get more complicated. Not because math people are evil, but because the real world is more complicated. So we got to get closer to that shit. All right, so I'm going to erase all this. All right. Now, if I had been smart, and unfortunately I'm not as smart as I wish I was, I would have looked at your survey answers and made a problem, but I'm going to do that on the quiz. So one thing I do with your survey answers is I make quiz problems out of your answers. I make the data you're going to use on some of the problems are going to be data about yourselves. And it's also informative for me. So I got to look back at them. I think maybe hopefully a few more people did it. But let's say I talk to, let's do this. Let's just say I talk to some retired people and not yet retired people. You guys with me? Retired people and not yet retired people. And I ask them something. I ask them something about, is the world worse, right? Than it was before. So yes, no, maybe. Is everybody with me? So I ask questions, and I've broken people up into retired and not yet retired. And let's say we get 7, 18, 2, 5, 3, 11. All right. This is not marbles. This is not cards. This isn't obvious. This isn't like an obvious probability question, but you can start to see I can ask all kinds of questions here. So if I ask you a question like, pick one person, what's the probability that they said yes? Well, what do I need to figure out before I can answer this question? So really, what
Total
should I?
amount of people who said yes.
Yeah, so I should do this. I'm sorry if I messed your notes up here. I should have put that up there first. I should total everything and then it can answer any probability question that's thrown at me, right? Since probabilities are based on counting, if I set up all the counts, probability is easy. So when will probability be more difficult? If I don't have stuff to count. That's when probability gets worse. So we're going to do several problems before we know any probability formulas. And then we're going to make probability formulas based on what we did. Okay. So how many people said yes?
25,
25.
Wait, sorry. 25.
25.
How many people said no?
7,
7.
How many people said maybe?
14,
How many people were retired that I talked to?
12.
How many people weren't retired?
34?
34. So how many total people did I talk to?
46.
Yeah, now watch, be careful. I'm going to write the wrong number. And I'm going to notice that my hair is in desperate need of a haircut. What do you think this person did? This is wrong. Don't write this down. What do you think this person did?
Added
Maybe.
both columns?
Say again?
Added both columns?
Yeah, they added this and this, but aren't these people, right? These aren't different people. All right, so they just cloned everybody and that gets weird. Let's not do that. Now I can answer any freaking probability question you throw at me because I've got all the counts. So what is probably somebody said yes?
25.
25 out of 46.
Good. 25 match what I'm looking for out of 46 total possibilities. Man, what the hell's that? I don't know. 0.547.
0.5.
I could be wrong. Go on.
54
What is it? 0.5, what is it?
0.543.
Go one more. 5, 4, 3,
4, 5, sorry, 5.
5, 4, 3, 5.
Mhm.
Yes.
Here's the next level of Jeff's evil. I want all probability answers to 4 place decimals. And then you can make them a percentage if you want to. Right? Agree with me? All right. I'm listening to somebody flip through books. Okay. What if I ask you now, what's the probability that I pick somebody who is not retired?
$34 out of 46.
Good. 34 people match not retired out of 46 total people, because it could be any of the 46 people. And then whatever the hell that is.
0.7391.
Coolness, coolness. Okay. So nothing too crazy so far, right? All right, so let's get a little crazy. I'm gonna have to race this here, you guys. You guys ready? So what if I pick one person? What's the probability that that person said no, or they're retired? So now the number of things that match what we're looking for is going to change, right? It's a or. They could have said no, or they could be retired. Now, what's wrong if I do this? 7 people said no, plus 12 retired people, so 19 out of 46. Yay! I just did something wrong. Anybody figure out if I do 7 people said no, 12 retired people, 7 plus 12 is 19, Jeff.
Because it says or and not and.
And careful now, and would mean you have to say no and be retired. Let's do that real quick. How many people said no and they're retired?
2.
Good. Only 2 people said no and they're retired. Do you guys see that? So get this. Has anybody ever gone to a club where they have somebody at the door and they have a line of people, and if you're on the list, you get in, something like that? Or have you seen that in movies, or have you lived it? So I go to one of these clubs and I go up to the bouncer, and the first bouncer says, to get into the club, you have to dress nice. Oh shit. Or, you have to be rich. Oh shit. Or you have to know Joe the bartender. I know Joe. Hey Joe. Hey Jeff. And I go in, right? Because it's or. I only have to do one of the things. Because or is all inclusive. So could more or less people get in that bar if I had an and bouncer? So here's the and bouncer. So you get in this bar, you got to know Joe the bar. I know Joe. And you have to be rich. We'll stop right. And you could have stopped. You have to dress nice. All right, I'm out of here. And is very restrictive. Has anybody ever looked up scholarships? Anybody? All right.
Yep.
Yeah.
Get this. Back in my day, kids, when I was walking uphill both ways to school, I had to go to the financial aid office, and they had this book, this crazy big. I'm doing it. It's not even open yet. So this book is like this thick, and you open it, and you start reading these scholarships. And the first line says, you must be a math major. Yay. And you must have this GPA. Just barely. Yay. And at the bottom, it says something like, and you must be from Dakota, North Dakota. I'm like, oh shit. right? So scholarships requirements are very often, and they are more restrictive. So less and less and less people are eligible. Is everybody with me? So and makes the number smaller always, or makes the number bigger because it allows more in, or more. Okay. So what is the probability of said no or retired then? What's wrong with me saying 7 plus 12? If I add these people to these people, what have I done wrong?
You're counting someone twice?
I'm counting how many people twice?
2 people?
People. So I could do 7 plus 12, 7 no's, 12 retired, minus 2, correct? Is everybody with me? Do you guys see why there's a minus? Because I counted 2 people twice, so I got to subtract them out once. Or I could have been smart about it, and I could have said 12 retired people plus 5 people I haven't counted yet that said no. Isn't 7 minus 2 5 anyway? Do you guys see what I'm saying? So when you can count stuff, there's a few different ways you can count what you need. No big deal. So I end up with 17 out of 46, which is whatever the hell it is. I don't know. We'll never know, Jeff. Oh shit, sucks. Let's see. So it's
0.3695.
okay. And what would this be? Somebody already gave this answer away. How many said no and are retired? Only 2. To see how that's and is also called intersection. Isn't that where they intersect right at 2? So 2 out of 46, whatever the hell that is. So 0.03.
0.0435.
0.0.
0.0435.
Thank you. That's it. You guys okay so far? So let's do 2 things here. Let me see. I didn't really give myself much.
Yeah, Jeff, the number above should be 0.3696 because the 5 rounds up.
Oh, okay. I don't know if you noticed I'm not doing them. I'm crowdsourcing this. Does anybody else agree with that? 3696 on this one? Anybody else do this one?
I have a question.
Yes.
So for I, you put 7 plus 12 minus 2. Where did that minus 2 come from again?
So if I count these 7 people, yes, because they said no, right? 7 people, and these 12 people, how many did I count twice?
2 people?
Yeah. So if I do 7 plus 12, I got to subtract 2 off because I counted them twice.
Got you.
Okay, cool. I like it. Or, like I said, you could have done this: 12 retired plus 5 no's I haven't counted yet. That would have still been 17 out of 46. Yes. So you could have just been more careful to begin with. Just don't count people twice. Billy's right. Okay, 3 to 6. That's it. I like it. So those are always crowdsourced. Right. I'm going to take this away. We're going to have to talk about and later, but I want to talk about or right now. I'm going to erase this one. Is that all right? We're going to make our first equation. All right. Hopefully nobody said no in the chat. Okay. So watch this. Stay on. The probability of an event or another event. So you know how X and Y are used primarily in algebra, correct? You guys would agree with me. In probability, we use A and B and then C if we need to. They're like the main variables. So what do A and B represent? Events. The event could be said no or a retired person or whatever. So what's the probability of an event or some other event? Somebody help me out. What was 7 out of 46? Where did 7 come from?
It was the amount of retired people who said no minus the amount.
No. Way too much. What is 7?
A total?
That's
Said
how-
no.
People who said
No.
No, so 7 out of 46 is the probability somebody said no. So probability of A or B is probability of A plus, you guys are with me the same way? This would be the probability of retired person, yes?
Yes.
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 The probability of event A plus the probability of event B minus, now we actually know exactly what this is. This is the and. Wasn't 2 out of 46 the and? So minus the probability of A and B. This is our first formula that we've created. I want you to remember, we did a problem before we knew the formula. So if I have the ability to count everything I need, I don't need these formulas worth shit. They are worthless. You're not used to a math teacher saying that because because in most math you need the formula, but here probability is based on counting. If I can count, I don't need the formula. So will there be problems when I can't count? Shit, yes. So this formula will have a purpose, just not always. So this is our first probability formula. We will end up with 3 main probability formulas. I'm going to erase these 2 lines. You guys ready? Oh, yeah. What about this? All right. I think we're on 5, aren't we? What's the probability that they are, that they said maybe, given that they're retired? Oh, shit. What's the probability that they said maybe, given they're retired? So what do you know about the person? This is different. I actually know something about the person. What do I know about the person?
They're retired.
They're retired. Good. So how many people could I be talking about?
12.
12. So the bottom is going to be 12. Given they're retired, can't I throw all these other people out? They're gone. I know they're retired. Out of those 12 people, how many said maybe?
3.
3 out of 12, 25%. So I really want this to make all the sense in the world. The bottom is always the total number of things it could be. The only time the bottom will change is if I know something about what it was. Because then I can eliminate some of the stuff it could be. So if I know they're retired, I can throw everybody out that wasn't retired. I can just throw them out. I'm only talking about 12 people now. That's
So then,
fine.
when are we like arbitrarily subtracting 1? I still don't understand that concept.
What do you mean subtracting 1? I don't understand it at all. What do you mean?
Earlier in the last lesson, we were doing standard deviations and we're subtracting 1 from the bottom number.
Oh, now wait a minute. All right, Billy. Does your question have anything to do with probability?
No, I guess.
Okay. So
I'll stop.
okay, it's okay. Those kind of questions have to come up in office hours or when we're talking about the kind of thing.
Okay.
I've talked about the N-1, I think 3 times by now, in different ways, right? There were the degrees of freedom, all that kind of stuff. So you can look at the video from last Thursday or the video from today, right? Or ask me after class. That's fine. Anything about this probability idea? Okay. So what about this one? Here, you guys do this one. I'll stay quiet. Marker. Okay. What's the probability that somebody is not retired? Well, that was a bad idea, Jeff. Good job, buddy. Not retired, given they said yes. All right, don't say anything. Don't say anything, don't type anything, just think about what the answer here would be. What does the bottom become now? Does somebody know?
34.
No. What's the probability they're not retired? So I don't know if they're retired now. What's the probability that they're not retired given they said yes?
25 is the bottom number.
So I know they said yes. So I'm talking about 25 people. Out of those 25 people, how many match what we're looking for?
18.
18. Like,
Wait, I have a question.
yes.
Wouldn't the bottom be 18? Because they're not retired and like the rest are retired.
You read this again. You ready? What's the probability that they're not retired? So I don't know if they're retired or not. What's the probability that they're not retired given that they said yes? So I know this person said yes. So how many people could it have been? 25. But and now I want to know what's probably they're not retired given they say yes. So out of those 25 people, how many are not retired? 18. What's the, all right, look, what's the probability that somebody's not retired? Just plain old not retired. I don't know shit about them, right? What's probably they're not retired? We did this earlier, I think, right? What's the probability that I pick a person and they're not retired?
34 out of 46, 73.91%.
Don't you see, it could have been anybody, and out of everybody, 34 were not retired. The minute I said, given they said yes, now I focus on this. Everybody else can just go away. 25 total people, 18 out of those 25 are not retired. I really want you to see that. We calculate it the same way. Here it was this many out of this many because it could have been anybody. Here it was this many out of this many because it could have only been these people. Right. What was 34 divided by 46 again? I'm sorry.
73%.
73.91%.
Sorry, say it again, sir.
73.91%.
I like it. Okay. And see how this is this the same as this? Obviously it's not the same, but it's pretty close, right?
Yeah.
So I want this, all right. We're gonna explore this idea more past just today, but if I know the person said yes, does that change the probability they're not retired much? If I know they said yes, does the probability that they're not retired change that much?
No.
Not much, right? It doesn't, it barely changes from 74 to 72, but it does change. Are you guys with me? Knowing they said yes does affect the probability that they're not retired. All right, so that's going to come up again later. Okay. So let's do this. I'm gonna, let me see. I'm gonna erase these last two lines and I'm gonna make a formula based on this one. I could have used this one, but I just want more room. You guys ready? I'm gonna do it. You're all like, you can erase all of that, Jeff. All right. So watch this. In general, what's the probability of A given B? Where'd that 12 come from? Where'd the 12?
Total number of retired.
Good. So it's based on the given, right? So the bottom is going to be based on the given. Now, where'd the 3 come from? Was it everybody who said maybe?
Retired who said maybe.
Yes, it was the retired and said maybe. If I know the person's retired, what's the only way they could have said maybe? They'd have to be retired and said maybe. Oh shit. A picture might help. So watch this. You guys ever seen this kind of thing? Venn diagram?
Yeah.
If I know, so what's probably of A given B? So I know B happened. I know, given B happened. I know B happened. What's the only way that A could have also happened? Where would it have to be? Could this have happened?
No.
No. So where's it got to be? It would have to
Have
be.
the shading and then inside the circle.
And this part is A and B. It's the overlap. So the formula for the given is this. The given tells me what the denominator becomes, and the only way that that could happen is if it happened along with B. Don't know if you guys are with me. But if you look at the other given problem we did, you can do the exact same reasoning to see where this would come from. And again, this is a formula we created after we did a problem. Isn't that crazy? Because probability is built on counting. I don't need formulas unless I have problems where I don't have all the numbers. Then I need formulas to help me out. Okay. All right. Let me think. I think that's not terrible. This might not be horrible to stop there. What do you guys think? This is not that terrible. We can stop there. We could definitely finish up chapter 3 tomorrow and then get into chapter 4 a little bit. Let me do this. Hold on. Don't go anywhere. I want to show you a couple things. Tomorrow, when we finish up chapter 3, I don't know if you're going to believe this or not, but I have a handout from chapter 3. Isn't that crazy? I'm not going to make it active yet, but there's a probability worksheet. And then on the other side of that probability worksheet that we're going to work on tomorrow, there will be a practice quiz for chapter 3. And then look, there will be answers for that. Oh my God, it's crazy. They're just not published yet, so don't yell at me that you can't find them because I haven't made them available yet. So that's what we'll do tomorrow. We'll finish up chapter 3. We'll get into chapter 4 a little bit because we're all crazy in this summer class. So for today, we're done. Let me know if you have any questions. Otherwise, you are free to run away screaming.
Thank you.
I'm fried, but I'll be back to do more homework tonight and catch up so I don't fall behind.
Okay. What time will quiz be open? So the quizzes, I'll always open them right when class ends. And then I'm probably gonna make it due the following evening. Sort of like I did with the last quiz.
Okay. Thanks, Jeff. I'm hopping off. I
Sure.
appreciate you, man. You're a great teacher.
Oh, cool. Thank you. The one thing, the comment I made last time is going to be applicable now because we're going to have a class. While some people still haven't taken the quiz. Quiz is asynchronous, yes. The midterm and the final are synchronous. All the quizzes are asynchronous, exactly. And please, dear God, don't miss class so you can do the quiz, and don't take the quiz while you're in class. I said that last time and it was not applicable because we had the Friday. It was awesome. But this time it will happen. Cool. And then I can jump into Discord, see what people are saying about me. Let's see. Let me know if you guys have any questions if you're still out there. You're welcome.
I had a question about, I really struggled with 2.4 of just like the reasoning behind some of it.
Which one, sorry?
Section 2.4, and then specifically, no, I'm sorry. I'm on the wrong one. I apologize. 2.3, when it got down to problem, I think it's 82, and starting to talk about like the reasoning why the median could be different
All right, so watch this.
Okay.